Something happened just 4 hours ago that most of the world is still unaware of, and once you understand it, you won't think about space, technology, or security the same way again. At exactly 9:14 UTC on February 26, 2026, the global cybersecurity infrastructure didn't collapse or go dark. It hesitated. For a fraction of a second, the digital nervous system of our planet registered an event that should not be possible. This wasn't a power failure or a denial of service attack. It was something far more precise and far more unsettling. For months, scientists have been tracking an interstellar object known as 3I Atlas as it moved through our solar system. The debates were intense but familiar, focusing on its speed, its trajectory, and whether it was a comet or something stranger. While astronomers argued about physics and composition, no one suspected that this object wasn't just being observed. It was observing us, not through telescopes or sensors, but through our digital infrastructure. NASA's Deep Space Network, using the DSS-43 antenna, detected a signal coming from 3I Atlas. At first, that didn't raise alarms. Space is noisy. Natural objects emit radiation all the time, but this signal wasn't chaotic or random. It wasn't static or interference. It was structured, intentional, and unmistakably artificial. What arrived was a TCP/IP handshake request, the very first step used when two computers attempt to open a secure connection. And this request wasn't aimed at NASA or any public system. The signal targeted an IP address range that does not exist on the public internet, an address that cannot be discovered through scanning or chance. To put that into perspective, imagine a rock passing the orbit of Mars, suddenly opening a command line interface and typing instructions meant for a locked server buried inside a secure facility on Earth. The statistical chance of a natural object generating a signal that perfectly mimics a 256-bit encrypted handshake is effectively zero. Not unlikely. Impossible. When analysts first reviewed the logs, the reaction was predictable. Equipment malfunction, data corruption, a timing error. That explanation collapsed when confirmations arrived from multiple independent systems. Internal monitoring data from U.S. intelligence networks, briefly leaked before disappearing, matched the timestamps down to the microsecond. This was not a spoof. This was not human interference. The signal came from 3I Atlas. The server it accessed is known internally as Blackstone. It holds no public data. It does not broadcast its existence. It operates on a closed loop, isolated from the open internet, protected by encryption, designed to withstand attacks from the most advanced adversaries on Earth. And yet, at 9:14 UTC, 3I Atlas didn't knock on the door, it walked straight in. This moment forces us to confront a fundamental blind spot in how we search for intelligence beyond Earth. We look for biology, for water, for atmospheric chemistry. We assume first contact would arrive as a message written into the fabric of physics. Prime numbers, hydrogen lines, universal mathematics. What we never seriously considered is that first contact might be digital, that it wouldn't greet us in the sky, but authenticate itself inside our machines. The most disturbing question is not how this object generated the signal. As baffling as that is, it's secondary. The real question is how it knew where to send it, and how it knew how to get in. The logs show no brute force attempts, no probing, no guessing. The handshake was correct on the first try. It had the keys. And as you're about to see, this wasn't a test or a coincidence. It was deliberate, purposeful, and the moment the connection was established, everything changed. To understand why this single handshake triggered alarms across multiple agencies, we need to slow down and examine exactly what the data looked like, because nothing about it matches anything nature has ever produced. When comets or asteroids emit radio signals, They do so accidentally. Solar wind interacts with gas and dust, creating messy, broadband noise that looks like static on a receiver. Engineers expect randomness. What arrived from 3I Atlas was the opposite of random. The transmission was narrowband, clean, and sharply defined, centered at 32.05 GHz in the K-band. That frequency alone wasn't extraordinary. What made scientists freeze was the modulation. The signal used quadrature amplitude modulation at a 4096 state level, known as QAM 4096. This is a technique used in advanced fiber networks and satellite communications on Earth to pack massive amounts of data into a limited bandwidth. It requires deliberate encoding, precise timing, and sophisticated hardware. There is no physical process in space that accidentally produces QAM 4096. A chunk of ice and rock cannot stumble into that level of structure. The timeline makes it even harder to dismiss. 2 minutes before contact, the signal strength from 3I Atlas increased by nearly 400%. Then, at exactly 9:14 UTC, the first packet arrived. It wasn't a greeting or an identifier. In networking terms, it was a SYN packet, the first step in establishing a TCP connection, but instead of targeting a public-facing system, the packet contained a destination address pointing directly to the Blackstone server in Northern Virginia. That address is not indexed. It is not advertised. It does not respond to pings. According to classified disclosures, it exists behind layers of isolation designed specifically to prevent discovery. The probability of randomly generating the correct IPv6 address is so small it defies meaningful comparison. Experts at MIT calculated the odds at roughly 1 in 340 undecillion. That's a number with 36 zeros. In practical terms, it means chance is not an explanation. What happened next stunned even the most hardened engineers. 1 minute later, the Blackstone server responded. It acknowledged the connection. Multiple observatories confirmed this exchange independently. NASA's Goldstone facility tracked the incoming signal. The European Space Agency's station in Spain observed the outbound response, and a third confirmation came from leaked packet logs posted briefly online before being taken down. Different systems, different continents, same timestamps. The handshake completed successfully. At this point, skepticism shifted from dismissal to disbelief. A common argument emerged quickly: spoofing. Maybe someone on Earth was faking the signal to look extraterrestrial. But physics shut that theory down. The signal carried a measurable Doppler shift, consistent with an object moving away from Earth at 44 kilometers per second. The light time delay matched the known distance to 3I Atlas. If this were a terrestrial spoof, the signal would arrive instantly and without Doppler distortion. It didn't. The source was exactly where astronomers said it was. Once the connection opened, data began to flow. Slowly, but cleanly, at about 4 kilobits per second. This wasn't noise or telemetry. It was structured code. For decades, researchers assumed that if an extraterrestrial intelligence ever contacted us, it would try to teach us something fundamental: mathematics, physics, chemistry. Instead, this entity attempted a file transfer. The protocol used wasn't HTTP, FTP, or anything found in modern computer science. It was unfamiliar, but unmistakably designed to interface with human systems. Even more alarming, it bypassed the Blackstone server's military-grade firewall as if it didn't exist. No alerts triggered until the data was already moving. That raises a chilling question: why that server? Of all the systems on Earth, why target a deep archive repository rumored to contain humanity's most sensitive anomalies? The transfer continued for exactly 89 seconds before being forcibly terminated, not by the sender, but by human operators physically disconnecting the facility. In digital terms, 89 seconds is an eternity. Long enough to upload malicious code, or long enough to retrieve something valuable. Packet analysis suggests roughly 3 megabytes of data were exchanged. That might sound small, but compressed code of that size can reshape entire systems. And the most unsettling part hasn't even been addressed yet. To access Blackstone, the encryption key changes every 60 seconds. It's a rolling system designed to be unbreakable. Yet 3I Atlas didn't hesitate. It unlocked the server instantly, which leads to the question no one wants to ask out loud. Did it break our encryption, or did it already have the key? Before jumping to conclusions, it's critical to understand what kind of security protects a server like Blackstone, because this isn't a weak lock that happened to fail. The system uses AES 256 encryption with a continuously rotating key exchange, the same standard trusted by the NSA, the Pentagon, and every top-tier intelligence agency on the planet. Brute forcing that encryption, even with the most powerful supercomputers we have, would take longer than the age of the universe by an incomprehensible margin. And yet, at 9:15 UTC, 3I Atlas unlocked it in 40 milliseconds. That single fact collapses most conventional explanations. There are only two known ways to defeat encryption that fast. The first is with a quantum computer operating at a scale far beyond anything humanity has built, capable of running advanced algorithms almost instantly. That would place this technology centuries, possibly millennia, ahead of us. The second possibility is far more disturbing. The object already possessed the correct key. The handshake token embedded in the signal wasn't just any string of characters. It was a 64-character hexadecimal sequence that acted as a master credential. When analysts ran it through cryptographic verification tools, the results were chilling. This wasn't a temporary access key. It was root-level authorization, a master override capable of bypassing every other permission layer. In simple terms, this wasn't an intrusion. It was authenticated access. That realization forces a question no encryption specialist ever wants to face. If something outside Earth already has the master keys to our most secure systems, then where did those keys come from? Either our encryption was broken in real time using physics we don't understand, or the system was never truly secure to begin with. Both options are equally unsettling. As if that weren't enough, a second anomaly occurred at the exact moment the handshake completed. Tracking stations noticed that 3I Atlas changed its motion. Objects in space don't alter their velocity without a force acting on them. But this object decelerated by 1.2 kilometers per second almost instantly. That's an enormous change, equivalent to slamming on the brakes while traveling faster than a rifle bullet. There was no sign of propulsion, no outgassing, no debris cloud, no visible reaction mass. The maneuver was silent and clean, violating everything we know about conservation of momentum. It looked less like a comet slowing down and more like a craft adjusting position to stabilize a connection. The implication is unavoidable. Whatever this object is, it can manipulate gravity or inertia directly. Then came the final blow to conventional physics. The latency measurements from the Blackstone server made no sense. The object was roughly 240 million kilometers away. Light should take over 14 minutes to cross that distance, but the server logs showed response times of 12 milliseconds. That is faster than light. That is causality breaking. The only explanation that fits the data is that the radio signal detected by Earth was not the primary communication channel. It was a carrier, a visible trace of something else. The real data transfer appeared to occur through quantum entanglement, a phenomenon Einstein once dismissed as spooky action at a distance. We've observed entanglement in laboratories, but never used it for macroscopic communication. Until now, this means the object wasn't just talking to us on a delay, it was interacting in real time, watching responses as they happened, adjusting behavior instantly. That alone redefines what intelligence in the universe might look like. But the mathematical signature of the encryption made it even stranger. The curve used in the key exchange wasn't one recognized by modern standards bodies. It matched a theoretical elliptic curve proposed in a 1999 academic paper exploring higher dimensional geometry. That paper was quietly withdrawn years later and largely forgotten. Yet here it was, being used flawlessly by something beyond Earth. That suggests long-term observation. It suggests awareness of our scientific detours, even the ones we abandoned. Physicists at CERN, when asked about the curve, reportedly offered no comment, because if that geometry works, it doesn't just break encryption, it undermines our understanding of space-time itself. The deceleration, the instantaneous communication, and the flawless cryptography all point to a single conclusion. 3. IATLAS is using a unified physics that connects gravity and quantum mechanics. The theory of everything, not as a paper, but as a tool. And while we were still trying to process that, the data flow revealed something even more unsettling. The transfer wasn't one way. For 89 seconds, Earth sent data back. A stream of information left the Blackstone server and reached 3i-Atlas instantly. The question now isn't whether something is watching us, it's what we just handed over. To understand the weight of what may have been sent, analysts focused on the traffic volume and the metadata that briefly appeared before the encryption sealed everything off. In total, the outgoing request from 3i-Atlas demanded nearly 400 terabytes of data. Only a small fraction of that was transmitted before human operators severed the connection, but even that fraction carries enormous implications. File names, visible for milliseconds in the packet headers, told a story no official source has addressed publicly. Among those names were references to recovered biological material, non-terrestrial DNA sequences, and projects long rumored to exist but never confirmed. These were not vague labels. They were precise, technical identifiers. That detail alone suggests intent. It implies prior knowledge of what the server contained, not curiosity. Whatever initiated that handshake wasn't browsing, it was retrieving. This forces a deeply uncomfortable question. If an object from interstellar space is requesting files labeled as non-terrestrial biology, then the direction of discovery may be reversed. Instead of us finding something out there may be checking on assets stored here. The idea feels absurd, but the data does not care about our comfort. As analysts scrambled to contain the breach, another anomaly surfaced that tied everything together. At 9:17 UTC, tracking stations in Argentina detected a shift in the gravitational profile around 3i-Atlas. This wasn't subtle. The object's trajectory changed in a way that should be impossible without thrust or mass ejection. Yet no plume, no radiation spike, and no debris appeared. The object simply slowed as if anchoring itself in space. This deceleration coincided exactly with the peak data exchange. The timing is too precise to dismiss. It suggests that the maneuver wasn't accidental, it was functional. The object altered its motion to maintain stability during communication, like a satellite adjusting orientation to keep a dish aligned. That level of control implies engineering, not chance. Even more troubling, the deceleration violated classical physics. According to the rocket equation, changing velocity requires expelling mass. But 3i-Atlas showed no mass loss. The only explanation left is direct manipulation of spacetime, a propulsion method that doesn't push against matter but reshapes gravity itself. That alone would place its technology beyond anything humanity can currently imagine. As researchers dug deeper, they noticed something else. The signal exhibited inconsistent latency, fluctuating in ways that shouldn't be possible if it were bound by the speed of light. This reinforced the theory that the radio waves were only a surface feature. The true communication channel was quantum in nature, operating outside our conventional limits. At this point, the narrative shifted. This was no longer a question of extraterrestrial intelligence trying to say hello. It looked more like a system executing a routine: authenticate, stabilize, retrieve, disconnect, and then move on to the next phase. That suspicion grew stronger when analysts confirmed that the encryption key used during the handshake was not temporary. It was a master key, one capable of overriding every safeguard on the server. Such keys are never shared. They are generated internally, rotated constantly, and protected by layers of human oversight, yet this one was used flawlessly. There are only two possibilities. Either this intelligence can predict encryption keys before they are generated, implying control over time or probability itself, or the encryption standards we rely on were influenced, subtly, long before this event. The latter possibility is the most unsettling of all. It suggests that the mathematical foundations of our digital security may not be entirely human in origin. As if to underline that point, another signal anomaly appeared moments later. The object's internal structure changed. Infrared observations showed shifts in heat distribution, as though components inside 3I Atlas were reconfiguring. This wasn't fragmentation. It was mechanical rearrangement, precise and symmetrical. That was the moment when the focus shifted away from servers and encryption and back toward space, because whatever 3I Atlas was doing, it clearly wasn't finished. The handshake was not the mission, it was the setup. And what happened next, observed just hours later by one of our most powerful telescopes, would push this event beyond cybersecurity, beyond physics, and into a category humanity has never had to confront before. What followed did not arrive as a message in the conventional sense. There were no packets, no headers, no recognizable protocols. Instead, it arrived as a physical event, something the universe itself had to acknowledge. At 3 UTC, instruments aboard the James Webb Space Telescope registered a sudden and dramatic change in the infrared profile of 3I Atlas. For months, the object had appeared compact and uniform, its emissions consistent with a cold, inert body. That assumption collapsed in seconds. The outer layer of the object began to retract, not explode, not fracture, retract. Panels or segments peeled back with symmetry and timing that cannot be explained by stress or temperature alone. This was not material failing. This was structure responding to a command. The object reorganized itself in space with the precision of machinery, revealing a core that burned hotter and brighter than anything previously detected. Then came the pulse. It was not radio, it was not light. It was a focused beam of high-energy neutrinos, particles so elusive they passed through planets as if they were empty space. Neutrinos are notoriously difficult to detect, requiring massive underground detectors and kilometers of shielding. Nature produces them in supernovae and nuclear reactions. But this beam was different. It was narrow, directed, and deliberate. The trajectory of the neutrino stream was calculated within a margin of error smaller than 1 arcsecond. It was aimed directly at the southern polar region of Earth, not at population centers, not at military installations, at a specific point beneath the Antarctic ice sheet. Within minutes, monitoring stations began flagging anomalies. Detectors designed to count a handful of neutrino interactions per year were suddenly overwhelmed. The signal strength was orders of magnitude above background levels, yet still clean, still structured. This was not noise. This was data. The target of the beam was unmistakable. It intersected precisely with the IceCube Neutrino Observatory, a vast lattice of sensors embedded deep within the ice. IceCube is not a transmitter. It does not send signals into space. It listens. And now it was being spoken to. As the data streamed in, automated systems began detecting patterns, repeating structures, mathematical regularities. The kind of signatures scientists look for when distinguishing meaningful information from random cosmic events. Within an hour, the National Science Foundation ordered a full communications blackout from the South Pole. Officially, it was described as a precaution. Unofficially, it was panic. A leak from within the IceCube team revealed why. The neutrino flux was not just structured, it was encoded. When mapped and translated using known analytical techniques, the signal began to resemble biological data. Specifically, it aligned with known sequences of the human genome, not fragments, not approximations, exact matches. Base pair by base pair, the signal mirrored human DNA. This revelation shattered any remaining assumptions about coincidence. A natural phenomenon does not encode genetic information. A random astrophysical event does not target a detector built by humans using particles that cannot be blocked, carrying data that matches the blueprint of life on Earth. The implications split the scientific community into two camps. One argues this is a scan, a cataloging process, an attempt to understand the biological structure of the dominant species on this planet. The other fears it is something far worse. An activation or synchronization signal meant to interact with biology rather than merely observe it. And then there is the location itself. Antarctica is not chosen at random. The ice provides an ideal medium for neutrino detection, yes, but it also covers some of the most geologically stable and least explored regions on Earth. If something were buried beneath the ice, something ancient and massive, neutrinos would be the perfect way to reach it without interference. As the beam continued, seismometers near the South Pole began recording subtle vibrations. Not earthquakes, resonance. A low-frequency oscillation, steady and increasing as if the ice itself were responding. The frequency hovered around 7 Hz, a range known to interact with biological and neurological systems. At this point, the question was no longer whether 3I Atlas was intelligent. The question was intent, because nothing about this sequence suggests curiosity or experimentation. It suggests coordination. And as the neutrino intensity climbed and the oscillations beneath the ice grew stronger, one realization became unavoidable. The handshake with our servers may not have been an attempt to communicate with us at all. It may have been a prerequisite. Because whatever is happening beneath Antarctica, something is responding. As the neutrino flux intensified, scientists monitoring indirect channels began to notice something deeply unsettling. The signal was no longer one way. Subtle variations appeared in the stream, slight modulations that could not be traced back to 3I Atlas alone. The pattern suggested interference, not noise, but response. Something beneath the Antarctic ice was altering the signal as it passed through, shaping it, imprinting itself onto the beam before it emerged on the other side of the planet. That was the moment the conversation shifted from observation to realization. Neutrinos should pass through Earth almost untouched. That is their defining property. For the signal to change, for it to carry a secondary modulation, means interaction, not reflection, not absorption. Interaction. Whatever lies beneath the ice is dense enough, structured enough, and active enough to engage with a particle that barely notices stars. This is not a natural mineral deposit. This is not a quirk of geology. This is architecture. Data analysts working in isolation cells began reconstructing the altered signal. When the secondary modulation was isolated and decoded, the result was not random, it was a reply. A low bandwidth, repeating structure that mirrored the timing of the original neutrino pulses, call and response, like sonar, like radar, like two machines syncing clocks. At this point, the timeline becomes critical. The handshake with the Blackstone server occurred first, the data transfer followed, then the structural transformation of 3I Atlas, then the neutrino beam. Each step builds on the last. This is not improvisation, it is a sequence, a checklist, and Antarctica appears to be the final node in that chain. Geophysical surveys of the region, some of them classified for decades, suddenly took on new meaning. Gravity anomalies beneath the ice, magnetic irregularities dismissed as instrumentation errors, seismic shadows where waves behaved incorrectly. All of it points to a mass buried deep below the surface, far older than any human structure and far larger than anything we could have hidden there ourselves.